Today we're going to be moving away from implementing audio using C# ever so slightly. We're instead going to introduce ourselves to Unity's audio mixer. We're going to look at what it is and learn about how we can use it to balance and control the levels of each sound, as well as the music of our game. We'll then look a little bit at routing our audio through different buses, or groups as they're referred to in Unity. So let's start by looking at what the audio mixer is and how to create one. So up until now, the signal path that our sounds took to make their way from our audio sources to our players' ears has been pretty simple. We already know that our sources send their signal to the audio listener, which is the point from which our player hears all of our sounds and music from. Well, the audio mixer and the audio groups that make it up sit in between the audio sources and the listener. Where audio sources and listeners were unfamiliar to us at first, the audio mixer should be more recognizable as it's designed and structured to work like a physical music mixer or software ones found in your favorite DAW. Just like how a mixer inside a DAW is made up of channels, tracks and buses, the audio mixer allows you to create audio groups which act in a similar way. Using these, you can send the signal that these groups receive to other groups in order to separate and group different pieces of audio depending on its purpose, and then mix them together. For example, you might have a channel dedicated to your game's music and sub-channels dedicated to music elements for each level of your game. Now you can create an audio mixer straight from the project tab of Unity. Before we make one, let's make our way to a folder that we'll place the mixer in so we can quickly find it later. So make your way through the following folders: Assets, Tanks, Completed Assets, Audio Mixers. Once inside this folder, we can create the audio mixer. To do that, simply right-click on the empty space inside the folder, select Create, and then Audio Mixer. Then we give it a name, so let's call ours Main Mix. And there we go. We now have our own mixer to control our audio with. Before we take a closer look at it, let's quickly familiarise ourselves with the options presented to us inside of the Inspector tab whilst the mixer is selected. Now, Auto Mixer Suspend, when enabled, will disable any processing effects you've added to your mixer, which we'll be looking at shortly, if your audio is playing at a level less than the threshold volume underneath. This is to save on processing power, as there's no point in Unity spending lots of processing power on effects that aren't even being heard by our player. We won't be making any adjustments to the settings here, but it's good to know that this is an option when working on larger games. We don't really need to worry about what update mode does. It simply changes which one of Unity's systems for measuring time will be used when calculating transitions in levels over time. Seeing as we haven't really looked at those systems, called game time and unscaled real time, we'll leave this option as it is. Okay, so to open up the audio mixer we've created, all we need to do is double click on it, opening a new window type for us to inspect it through, the audio mixer window. Now the audio mixer window is pretty easy to understand, so let's quickly run through it. As mentioned, our audio mixer is made up of different groups which we can send our audio through. By default, every mixer starts off with a single master group, which we can see in the middle. This is the last group that an audio signal sent to this mixer will pass through before being sent to our audio listener. We have a few buttons on it too, which all other groups will also have. The S will solo this group, the M will mute it, and the B will bypass any effects added to it, so that only the original signal is heard. If we then click on the group, we can take a closer look at what it will do to our audio in the Inspector tab. So we can see that we have a couple of options for changing the level of volume outputted from this group, as well as the pitch of the audio too. But if we wish to add some more effects to this group, we simply click on the Add Effects button, which we'll be doing later on. Now, one master group on its own isn't going to be very useful to us, so let's create a few more to send to this master. To create new groups, simply click on the plus icon next to where it says Groups on the left hand side of our audio mixer window. Now we have a new group that will send its signal into the master group. We'll call this new child group Music. And later on, we'll look at sending our music into it. Let's do the same thing again and create another group that we can send to this master group. Now before we do, notice how our new music group is highlighted in the groups section. If we were to click on the plus again, whilst it is highlighted, the next group that we'd make would be a child of the music group and not the master group like we want it to be. So let's first select the master group and then click on the plus icon to make another new group, which this time we will call SFX. Great, so now we have two new child groups of the master group. Now what we can do is tell some of the specific audio sources in our scene to send the audio that they play into one of these groups before the audio listener. Let's start with our scene's music. Let's select the music object in our hierarchy tab. Next, in the inspector tab, underneath the audio clip our source is playing for us, let's click on the small circle that sits to the right of the output field. We can now select which mixer and which group within that mixer we wish to tell this source to send its audio through. So let's select the music group. Great! Now by making changes and adjustments to the music group, we can affect how our music being played from this source will sound. Now the rest of the audio sources in our scene can be sent to our SFX bus, as they all play sound effects. So far we've added quite a few audio sources to our game that play sound effects, such as on the tank prefab, on the tank shells prefab, on the power up objects prefab, and on the jack pump objects. So let's go through our project, find these objects that we've attached audio sources to, and set their output to our SFX bus. Don't forget to check the prefabs of those objects too and save any changes you make to them so that they carry over into your game. Now I'm going to quickly do that to my project off screen. So go ahead, pause this lesson, make those changes to your project, and then hit resume once you're ready to continue. Okay, so hopefully every audio source in your project should now be sending the audio that they've been told to play through one of your groups in your mixer. Now that the signal path for our project has been set, let's look at what we can do to our new groups. It's a common struggle when it comes to mixing video game audio to try and find the right balance between your music and your sound effects. You want both to be heard by the player without one drowning out the other. The most obvious thing to do is to adjust the faders on both of our groups until we find a balance between them. For example, I'm going to set my music group fader to about minus 12 dB so that my sound effects can be heard. However, this alone will feel very limiting and static, as you'll want your music and sound effect volumes to change dynamically as your game progresses and different pieces of audio are played. Well, what we can now do is use a common technique that you may be familiar with if you've ever done any music mixing in a DAW, and that's volume ducking. We can tell the music group that our music is being played through to drop in volume by a certain amount whenever a sound effect is played through our SFX group. Before we do that, let's quickly go back to the audio source on our music object. Now up until now, we've done a very light bit of volume balancing to our music on this audio source, which is the best way to control the volume of a 2D music track such as this. But seeing as we now have a music group to work with, and we only have this music in our entire game to work with, let's make things easier for ourselves by setting the volume on our source to full, and then controlling its level using our group. Now of course, we also created a script to fade in our music at the beginning of our game. So we won't actually set the volume field on the audio source itself up to 1, its highest value. Instead, we'll go down to the music player script and we'll set the volume end field to 1. So now our volume will fade in from its most quiet value of 0 to its highest of 1. Great, now let's go back to our audio mixer and take a look at the music group. So the first thing we want to do is add the duck volume effect to our music group. This acts like a sidechain compressor in a DAW. A signal is sent to the duck volume effect specifically, and it then lowers the volume of our music group depending on how loud the signal it receives is. So we'll want to then add the duck volume effect to our music group and then send the signal coming from our SFX group to it. To add the duck volume effect, let's first select the music group in our audio mixer. Then inside of the inspector tab, let's click on add effect and then select duck volume. And we now have our first effect attached to our music group. Now, if you're familiar with compression at all, the adjustable fields that we can see on the duck volume effect should be pretty familiar to you. But if you'd like to learn more about what each one does, I'll have a link underneath this lesson which explains them for you. The main field we'll need to adjust is the threshold. This is the minimum volume level that our SFX group will have to reach in order for our effect to lower the volume of our music group. I'm going to set mine to -46 dB. Ratio is the amount you want your volume to be reduced by, which I'm going to set to 250%. Attack and release time determine how quickly the duck volume effect takes to activate and reduce the volume once the threshold is reached, and how long it takes to release after the signal drops below the threshold again. The attack I'm going to set to 0 milliseconds, and I'm going to leave the release as it is. Of course, with any of these settings, feel free to experiment and set your own values. Try some out and then listen to how the music and sound effects sound together in your game. If the music drastically drops when a sound effect plays, then you have set the ratio too high or the threshold too low. Now that we have our duck volume effect all set up, it's time now to send a signal to it that will influence our music's final volume. As you can see at the top of the effect, we know that there isn't a signal being sent to it just yet, as there is a warning message that says no send sources connected. Well, to fix that, let's now click on our SFX group. So to send the signal that this group receives to the duck volume effect, let's click on Add Effect one more time. And this time select Send. Sends are pretty simple. All you need to do is add one to a group and then decide where you'd like the signal to go. You must make sure that the group you'd like to send your signal to has a receiver effect on it first, however. Thankfully, our music group's duck volume effect acts as a type of receiver, so we don't need to add one to it. So let's click on the drop-down tab next to the word receive and select a destination for this signal. Obviously, we want it to go to our music group's duck volume effect, so let's select that. Finally, we need to decide how much of the signal we want to send. And personally, to make things easier to control for myself, whenever I create a send and route it to a duck volume effect, I always set the send level field to its maximum. That way I have full control over the signal through the duck volume effect itself, rather than trying to find a balance between the threshold, ratio, and sender level fields. And that's everything. Our music will now drop in volume whenever a sound effect in our game is played, sent to the sound effects group, and is louder than our set threshold. The last thing we need to do is test our game and listen to see if we're happy with the values we gave the settings of our duck volume effect. Now, we want this effect to be a subtle one. We don't want our player to notice the volume of our music drastically changing every time a sound is played. Despite that, the effect should still be noticeable enough to us when listening for it, so it's important to get these settings right and test them thoroughly. If you're struggling to notice any change in volume or find that balance, then you can always click back on your music group and keep an eye on the visual meter that the duck volume will show your routed group's signal through as you test your game. So once you're happy with your settings and you can see your effect in the inspector clearly, it's time to test your game. Okay, so as always, our music fades in and we don't hear any sound effects straight away. So now let's have a listen and see if we can hear music duck if we fire a few shells. Now, personally, I can hear my music duck, and I'm quite happy with both the amount that's being loaded and how long it takes to duck and then return to normal. However, if you're not, then you can make changes to your duck volume effect, or just your mixer in general, by clicking on the Edit in Play Mode button in either the inspector or the audio mixer window itself. So let's say I wanted my music to drop by an even greater amount. I might lower my threshold slightly, or increase my ratio. Let's have a listen and see how that changes things. And yes, the volume duck definitely sounds more drastic. Now what's good about the edit in play mode button is, unlike the changes we might make to our game objects whilst our game plays, the changes here actually save and remain even after we finish playing our game. So we don't have to remember the changes if we wish to keep them after testing. Now before we wrap up this lesson, I encourage you to experiment a little bit more with the mixer groups and the effects you can add to them. For example, you may wish to add an EQ to your music to control the frequencies heard by the player better, or maybe add distortion to your sound effects. It's up to you. But with that, we now have a simple but sound understanding of how to use and interact with the audio mixer. Now the audio mixer is the tool that's really going to not only add that final layer of polish to how your game sounds, but also give you the most control over the sonic experience your player receives. So it should be no surprise that we're not quite done with it yet. As in the next lesson, we're going to do what we've been doing with every other tool in Unity in this course, and that's learn how to interact with it through C#. So like I said, adjust those settings on the duck volume effect and add some other effects and sends to your groups too. Once you feel comfortable, head on over to the next lesson where we'll be learning all about the Audio Mixer's snapshot tool.